Before to conclude the description of all the settings, mental ray settings under the indirect lighting tab, I would like to just show you that the technique that I just explained to you to freeze the final gather map is discussed in many threads at CG Talk, like this one for example. And as you can see, the guy is using the same technique. First he set to off the rebuild, then he give a name to the map, and if you scroll down you will see the next he input freeze for the rebuild option, just as we did before. Plus I would like to show you that the technique that I just showed you for the final gathering map is quite similar to the technique used for the irradiance particles. This is actually the very famous thread Importance and Irradiant Particles on CG Talk, where Dagon explains exactly how to freeze the map. The irradiance particle map is a very similar workflow. If you read, but if you generate an uninterpolated IP, means irradiance particle map, and you freeze it, you raise your rays, and then you switch for the interpolated map. Now only the last IP, means irradiance particle pass, for the primary rays is calculated with high rays, and the other are reused from the original low rays. It's a little bit tricky, but it works. And I also would like to show you that this technique was described in my previous tutorial, as you can see. Let's scroll up 1 second. My previous tutorial at Gnomon, you see, mental ray importance and irradiance particles. And let's scroll down again. Here, this technique with the irradiant particles is called the uninterpolated IP. At least I call it like this. Interpolate never. And first implemented by Dagon and based on the final gather map freeze. And with this method the final irradiance is computed during the ray tracing. Let's go back to the big Maya scene and again all the window open, and let's scroll down in the indirect lighting tab. As you can see, the irradiance particles is disabled by default by final gathering, but it's not true. And I think you noticed from the output window when I was rendering the final gathering map just a few minutes ago that mental ray was calculating the importance but not the irradiance particles. I will go back to this small bug of mental ray, which is actually not a big problem, because you can with the string option you can enable both the final gathering together with the irradiance particle, and they are compatible now in the new mental ray 3.8 version. So skip the irradiance particle section and let's go down to the ambient occlusion. In this case, ambient occlusion I didn't enable because it's the same switch or option that I described before here, that is located under the features tab, which should be enabled to force mental ray to compute the ambient occlusion for the mental ray render passes feature. It's the same I show you. If I enable here, automatically is enabled here too. If I disable here, is disabled here. Here there are a few settings. I always go with this kind of settings. The number of ambient occlusion rays used for computation of each ambient occlusion value. Mental ray shaders using ambient occlusion can override this value. And I always use these settings. because are stable for me. Means by beta testing, by trial and error, I find that this works. But with this scene, since we are not using any passes, any mental ray render passes, we don't need to enable this option. So just uncheck this option. Now just select the last tab in the mental ray render setting panel, which is the option tab, and we will skip all this section because for example, these are global overrides, global illumination and caustics override. In the few years ago, we used to enable this, which is the global illumination generating, is a global override for common render settings, okay? And we used to use these two fields, you see these two drop-down menu, we used to enable set to on, but before to do that, we used to, this is the old school, okay, it's just to make you remember. We used to select all the objects in our scene, all, and then we enable. This is the old school, okay, to make sure that global illumination will be computed for all the objects and the material which are assigned, the shaders, the mental ray shaders assigned to the objects selected. This is just to remind you about how in the old times we used to use mental ray. Anyway, you can safely put back to none. And let's scroll down more. I think we can skip all these settings because I would like to draw your attention mostly on this one. One second. This one, sorry, is under the custom entities section and is the pass custom alpha channel option, which I usually enable for in all my production scenes for the reason that I use often mental ray custom shaders, like the shaders of Puppet that I showed you before. Traditionally, options named are hard-coded in the ME is the format of mental ray syntax, and in the data structure of the programming interface. New options are implemented as arbitrary named value pairs, means there is pairs of value names, where the name of the option is a quoted string, and the value can be a Boolean string, an integer, a float value, a 3 float value, or a 4 float value. Scroll down a little bit. These are the values. As I showed you before in the presentation, this is the name and the value can be on and off. This is the name and the value can be a string. Name, the value can be an integer. This is the name again of the string and the value can be a float. the name, and 3 float values. The name means the description of the string, and 4 float values. Let's scroll down a little bit more. And in the description of the string options, in the online help, by convention, option names consist of multiple words separated by a blank space, where the first word specifies the logical group or affected feature of the option, as in the case of the final gather mode string options, which is set to automatic. Automatic is the value. The string options provide a more general and flexible syntax to specify option in the ME format, the mental ray syntax format. The syntax does, however, not specify the semantic on how specific options are used by mental ray. It is also possible to provide options which are not known by mental ray but could be used by custom shader packages using the C++ programming code. Below are listed the environment lighting IBL, the progressive rendering PR, and the array string options. Let's scroll down a little bit in the PDF, and these are the string options. Actually, these are the IBL environment lighting string options. So you see these 3 lines of code. Actually, what happened? This is the first line, which instructs mental ray to create the string option 28 with the name environment lighting mode. This is the name of the attribute. The second line, as you can see, instructs mental ray to create a string option in the ME default option node that soon we will see, and with the type, string. This is the type of the attribute. This is the name of the attribute. This is the type of the attribute. And the third line instructs mental ray to create under the ME default option node the string option number 28 and with the value light. Let's quickly look at the second string option just to make it clear. And in the second string option, the name is set to environment lighting quality. This is the name of the string option, and the second line instructs mental ray to create the string option 29, and the type of the string option is set to float, as you can see. And the third line, which is this one, is set the value of the string option 29 to be 0.2. These are the default values when the string option, the IBL, the IBL environment lighting node string options are created. Of course, I will not read all the string options for you, just scroll down a little bit more. And let's give a look to the mental ray 3.8 progressive rendering, the PR string options. In the first line, the string options is set, the string option 34. The name of the string option is set to progressive. This is actually the first string option that enable the progressive rendering, PR, okay? And the type is set to Boolean. Boolean could be on or off, as I told you before in the presentation, or true or false. In this case, by default, is set to on. They use the Boolean value on and off. On enables the progressive rendering PR string option. As I showed you before, you can use also the true, the value true, or the value false. It's just a matter of syntax. Let's give a look to the second string option number 35, which instructs mental ray to create the string option 35 and to set the name to progressive subsampling size. This is the name of the string, and the type of the string is an integer. Integer means you can input a name, it's not a string like before. like we see before, string is this one. When you instruct mental ray to create a string option and you set the type to string, you must to input the value must to be, let's say, a word. In this case is sparse. It's not a word, it's an instruction, okay, it's a command, this is programming. But when you set the type of the string option to be an integer, you must to input a number, a value, okay. Now scroll down to the array string option, which actually are only two. Actually is only one, but I show you in this case that you can use both the value, since it's a Boolean value, for the type of the string option here, as you can see. So the first line instruct mental ray to create the string option 46 and to set the name to array. The second line instruct mental ray to set the type to Boolean, and the third line set the value to on. By default the value is off. To enable the array mental ray render engine, you must to set the value to on. I provide the second line just to show you that for the value of the string option, of the array string option, you can use the value true as well. It's absolutely the same. If you scroll down more in the PDF, you will see that I provide the description, always from the main My Online Help, of the different values that you can input in the string option. And example, for the IBL environment lighting mode, you can input off, the value off, the value light, and the value approximate. Here there's the description, means enable the built-in IBL mode for final quality if it's set to light, or for preview quality in interactive application with the value approximate. The default value is off. And let's give a look to a few other. Environment lighting quality. This controls the quality of the IBL contribution, the contribution of the HDRI image that we will use for the in conjunction with the IBL string option. The quality value can range from the value int 0.0, sorry, to the value 1.0, means from the value 0 to the value 1, for lowest to highest quality. The default is set to 0.2 for speed, because more you increase the quality, more the rendering will take time to render. This is an important one too. The environment lighting shadow string option, the value can be set to off, to solid, or to transparent. This attribute, this value, controls the shadow cast by IBL. Disable shadow casting if it's set to off. If it's set to solid, it enables opaque shadow, means shadow which have no transparency. Or if you set the value to transparent, it enables the full shadowing effect of the shadow, means you can see also the transparency in the shadow. The default value is set to transparent. The other settings we will see later, but let's scroll down a little bit more and see the different settings of the progressive rendering PR string options. So for the progressive string option, the value can be set to on or off to enable the progressive rendering, and the default is off, of course. For the progressive sampling size, this enables and controls the coarse sampling of the first image. The default is 0 for disabled. Let's scroll down a little bit more. Value greater than 1 activates subsampling mode in blocks of pixels, and the value specifies the size of the pixel block, where initial samples are placed first, typically displaying as a coarse image with the impression of lower resolution. The larger size, the coarser the initial image. Those pixels in a block which have not been rendered yet are filled with color values according to the setting of subsampling mode. The value of the progressive subsampling mode string option can be set to sparse or to detail. It controls the appearance of subsampling pixels which are not yet rendered yet, and the default is detail. If set to sparse, the unrendered pixels are set to black. This produces image with missing pixel, giving the impression of noise. I will show you in a few minutes how it looks. If set to detail, then pixels which have not been rendered yet are interpolated from the nearest surrounding samples, and this displays as a smooth image of lower resolution. The progressive subsampling pattern string option can be set to linear or to scatter, these are the values, and controls in which sequence the samples are computed. The default is scatter. The default value is scatter. If set to linear, then pixels are computed in a line-by-line, parallel order within a pixel block. If set to scatter, then the pixels are rendered in a quasi-random order. Now let's scroll down to the values that you will likely use the most, which the first means the minimum samples you will not use much because it's set to the default value of 4 and set the minimum number of samples per pixel for progressive renderings. But you will definitely change often the maximum sample, the progressive maximum sample of value of this string option. The progressive max sample string option set the number of samples per pixel to stop progressive rendering and erase. Actually, that means the default value is set to 100. For this will stop the progressive rendering from rendering, and you can set it to different values. It depends on the scene, on the complexity of the scene, and the result that you want to get. More sharp and less noisy rendering, more high should be set this value, and this value actually controls the main the rendering time, because when the PR, the progressive rendering, will reach the value 100, it will stop. If this number of samples per pixel has been rendered, then it will stop the progressive rendering automatically, regardless of any other stop criterion. Please note that to control the rendering time, the progressive rendering PR string option feature, okay, let's call it sampling feature, mint-array sampling feature, is the progressive max time string option. Before we see the progressive max sample, correct, which controls also the how many samples will take before the progressive rendering will stop. You can control the time directly with the progressive max time tool, and it set the time in seconds when to stop the progressive rendering and erase. The default value is unlimited. You can set a time to say, okay, enough, now I want the progressive rendering to stop. If progressive rendering has run the given number of seconds, then it will stop automatically. Another very important string option is this one, the progressive error threshold. This is it set the error threshold to stop progressive rendering and erase. The default value is 0.05. This is a very important attribute, and I will show you. because it really, if you decrease this value, example, if you decrease this value to 001, for example, the render will take more time and the contrast will increase and the quality of the image of the progressive rendering, the image obtained by the progressive rendering will increase. Let's see the description. If this relative error threshold has been reached, then stop progressive rendering automatically. A value of 0.0 targets perfect quality and won't stop rendering, means will take forever. A value of 0.5 will stop rendering already at a very low quality, means you will get the progressive rendering sampler will stop very early and you will get a low quality image. Note that this setting has lowest priority to determine if progressive rendering should be stopped. Now, what I would like to show you by open one of the main Maya scene, one of the big one. If you remember before in the description of the AA, the anti-aliasing quality settings, located under the quality tab of the main render setting panel, I draw your attention on the anti-aliasing contrast value, which is must be set in this field. You remember I told you that is set usually set to 0.1 and is the anti-aliasing contrast in the primary frame buffer to drive the adaptive oversampling, remember? And I also told you that if you decrease this value to, let's say, 0.05, the contrast and the quality of the image will increase, as well as the rendering time. As you can see, this is these two values, means the anti-aliasing contrast and the progressive error threshold, actually are very similar and give the same result, just with different way of rendering using mental ray. But these values are very similar and give a similar result.